Came across a book on abstract algebra, an old book. It's a second edition, John T. Moore, but it's one of these, what I would call the forgotten books. There are several books like that in every math subject, but I find this book to be very interesting, and I'm thinking of it being one of my early reads once I get going with abstract algebra. So this book is by John T. Moore from University of Florida and Toronto. And the thing that I really like about this book, well, number one, is very readable, and I appreciate that a lot as a self-learner, but also it's a very soft build into abstract algebra, and it does groupoids and semigroups and monoids before it does groups. It also does groups, then rings. Now, some groups do rings, then groups. But I really wanted to have at least one book that started building the basic algebraic structures from the simplest ones to the more complex ones, and was just like somebody talking to me. I really like it. And so I have read over one of my vacations recently, I read all of chapter 1 and chapter 2, and I even started reading chapter 3. But again, chapters 1 and 2 are really things that are pre you getting into the actual meat of the thing, which it really begins with chapter 3. So I really like this general algebraic systems approach where it talks about groupoids and semigroups. Jacobson also talks about semigroups, but I don't think I have another abstract algebra book that starts that basic. They really go into either groups first and do rings, or go into rings and do groups. So I really like this book. The notation's a little, it's a little old. I'm sure that when I read it, it'll be like other older books that I've read, where in some places I'll have to look up what is that? What does that mean? What does that symbol really mean in modern terminology? But so far from the little that I've read, it's very interesting, very well read. It's got references. It has some answers in the back. And actually, it takes a very different approach to answers, which is that it picks a couple of problems in a section. It'll have 2 stars, and it actually works out the problem. So it's almost like an exercise book. So I like that a lot. I really like this book. I wanted to show, because it's what I'm talking about, but I don't have an example of this diagram, but for abstract algebra. What I mean by as the reason why I find this book to be very attractive to me and why I think I'm going to read parts of it is because I really liked books like Dugunji when I was looking a little bit at topology. I didn't do a full look, but I did get started in the basics because I was doing point set topology. Not completely, I have to revisit it, but either way, I found this diagram in Dugunji to be fantastic because it really shows you how you go through and you put in more and more restrictions until you get to a point where you have a complete metric. And so all these different topological spaces map to something in mathematics, right? And so the same way, and I don't have a diagram for it for this book, but I know there is one in Wikipedia where all the different algebraic structures are sort of linked. And so, yeah, again, John T. Moore, definitely plan to do something with this book because I want somebody to build it for me, build all the algebraic structures by the rules and saying, okay, now you add this, now you add that. Okay, so you added this other thing, and now you're going from a ring to a field, and so on. So there it is. He also has 2 linear algebra books, but I'm so overloaded with linear algebra books that I don't want to get any more. At some point, you pass from being a self-learner who has a small collection of books to get yourself to the next phase and become sort of like a junior library, and I don't want to go there. I don't have the money for it or the space.